I'm Dr. Bob L. Head, and this is... In this episode, we will discuss the particle-wave duality of light and matter, the people and experiments that made the discovery possible, and how this discovery led to the birth of modern physics. Let's begin. In the 1600s, some scientists, including Isaac Newton, believed that light was made of particles and would obey Newton's laws of mechanics, while other scientists, like his arch-rival Robert Hooke, believed that light was made of waves because the particle model didn't explain phenomena like refraction and interference. Then along came Thomas Young in 1801 when he conducted his famous double-slit experiment demonstrating the wave-like nature of light. In his simple experiment, Young shone monochromatic light through a screen with two slits. On the wall behind the screen, Young observed alternating lines of light and dark, representing areas of constructive and destructive interference of light waves. This was some pretty strong evidence that light was in fact a wave. A little while later, James Clerk Maxwell came along with his famous equations and was able to describe light as transverse waves of oscillating electric and magnetic fields. So that's it, right? Case closed. Light's a wave. Wrong! Along comes my homie Albert Einstein in 1905 to solve the photoelectric effect, a discovery, by the way, that won him the Nobel Prize. To solve the photoelectric effect, Einstein hypothesized that light must exist as tiny packets of particles known as photons. Thus, the wave-particle duality of light was born. But it didn't stop there. Later, de Broglie proposed that matter would also exhibit the wave-particle duality the same way that light does. De Broglie's hypothesis was later confirmed by Davison and Germer, who performed a modern version of Young's double-slit experiment, this time using an electron beam instead of light. Davison and Germer observed alternating patterns of constructive and destructive interference, just like Young back in 1801 with his monochromatic light. The results of Davison and Germer's experiments confirmed that matter too could act as both a particle and a wave. This discovery marks the birth of modern physics and the quest for some of the greatest minds of our time to mathematically describe what is known as the wave equation. And that's all for today, folks. Thanks for watching. And if you enjoyed, subscribe to my channel and like this video. If you have any questions, leave them down in the comments below. I'll be happy to answer them. And join me next week when we discuss Schrödinger and his sadistic nature towards cats.